I'm going to jump right in here, reintroduce myself. My name's Cory Eicher, and I'm founder of Eicher. We're small, Charlottesville-based implementation shop, and we focus on software consulting and implementation, mainly focused on geospatial data and applications. So I'm excited to talk to you today. This is my adopted hometown here, and really excited to see so many people here talking about data, Python, and other topics related. So in the spirit of kind of asking a few questions, why are we here? Well, we know that data drives decisions. What should I wear today is one of those questions sometimes we ask ourselves. We might check the weather on our phone and see what we should wear. Or in more of a business or still, I guess, a personal context, where can I find something? Where can I find a breakfast burrito in this town? This is something I ask myself anytime I'm in a new town, and I might ask Google Maps, so that's a commercial mapping application, and it gives me some geospatial information. If I'm a business, for example, if I'm an internet data center operator or somebody planning data center doing site location, I might be interested in spatial data about the location of infrastructure, power infrastructure, telecom, and other information, perhaps risks related to the locations of those sites. And I'll talk today about how we can download or obtain and download data from OpenStreetMap in those themes, and walk us through some of the steps for that. And I don't want to put out questions here without answers. So the answer to what to wear is always dress in layers. We all know that. This Unicorn Gomez, this is a legit place for breakfast burritos, and they are open at 7 and they are open tomorrow. So check them out on Long Street. And yeah, I already talked to you about the angle here for the data center scenario, siting close to Anna backline power. So some stuff we'll walk through today. OpenStreetMap data. How do you get at it? How do you automate extracting that data, transform it for your use? You to talk a little bit about geospatial data formats, just the ones that are relevant to this data flow. And, I want to do a lot of demo, but we'll see where we get in terms of time. So here's the problem, the business problem, and the solution. The client, this is a real example. They're a global data center operator. They provide IT services, and they're interested in all sorts of information about infrastructure. So they wanted access to geospatial data specifically related to collector power, and they also wanted it in GIS format, Geographic Information Systems format, for downstream consumption, analysis, mapping, etc. And they wanted this data for a pretty large geographic footprint. They operated Europe, Middle East, Africa, so that was the extent of the data that they're interested in. I put the parentheses at the bottom. As the provider, we had to make a decision. Of course, it makes sense for this type of extraction and to automate, right? So they weren't telling me we need to automate. Certainly, this isn't something you would probably think about clicking your mouse, 1,000 times. So the solution is implemented in Python. We use an API called Overpass API to get at the OpenStreetMap data. And for a couple of different reasons, we also used a licensed Python package called HeartPy, which comes from the Azure Commercial GIS provider. So just a quick little, I guess this is a bit of a tease. We're looking at some output here from the process, fairly raw in terms of visualization, but we'll be able to answer the questions like, what are these green dots? We're looking at the south coast of England as a hint here. What is this array of red dots off the coast? Or if we take a look at a little bit different extent, what are these red lines? Why are some thick? Why are some thin? What are these mysterious blue circles? And these aren't just graphics, so they're objects with attribution. So what does the attribution look like when we obtain these data from OpenStreetMap? So diving into technical solution, this is what you see when you go to the destination site. It looks like StreetMap. That makes sense. It's in the name of their site. And it's object-based or vector, if you like to use that terminology. We can interrogate the data. We can use their little interrogation tool to pick the Violet Crown Cinema. Violet Crown Cinema has attribution. And I think in this space, perhaps many of you, but not all, are aware that OpenStreetMap is community sourced, right? So it's a two-way street. Their destination site supports editing. In fact, individually contributed and also organizationally contributed data are how OpenStreetMap have their data, right? So it's crowdsourced, if you will. They have a destination site, but behind the scenes, or I should say not shown on a destination site, are telecom and water and power data that we can get at through APIs, and then we can use that to support our business cases. Challenges include quality, geographic coverage can vary, consistency. I'm going to talk a little bit about that topic just here on this slide. So the attribution or attributing system that's in place in OpenStreetMap is incredibly flexible. Okay, it's practically wide open. It's a system of any object can actually have any number of key value pairs attached to it, tagged on that object, and that is the system. So there are some conventions, there's some documentation, there's some reviewing and acceptance of data that's contributed to the system, but it is so flexible that this tagging system is used for everything from categorization to names or labels, right? So the fact that something is a power plant is just a key value pair. The fact that the name of this building here is Violet Crown Cinema is that name is also just a key value pair. I stole this quote from one of the documentation sites, but as of early this year, we're pushing 100,000 distinct keys. So that's just the keys that are used in data that are globally in the OpenStreetMap system. So there's kind of a lot going on, and what that means for us is if we are seeking certain information, it's on us to read the documentation, understand what the guidance is about how information is supposed to be tagged, but also then, and I'll show you here, we also, it's well worth our time to look at the actual data and understand if perhaps there's alternate tagging that we might also want to pull down, or else we're going to be missing some of the information that we're looking for. So here's kind of just stepping one step deeper into this. Here's the documentation page for the key power, and this is their convention for categorizing objects as in the category of electric power, more or less electric power. And we can see some of the examples on the screen here: power plant, power pole, substation. You get the picture. So we can read all about that. We can also see some data about the frequency that we might find that tag. And so it's a little bit hard on this slide, but we can see from here there's north of 42 million objects in the OpenStreetMap data for just the power key. Of that, there's about 35 million nodes, right, point data, and there's some 6 million of what they call ways, and those for us in the kind of geospatial world, those are the lines and the polygons. So if you go to this tag info site, you can do or you can get some information to kind of help you do what I was just talking about. If you're looking for power data, it might help you to understand, well, what all is in there. And so here's some frequencies. There's also some nice visuals in here. So you can kind of, if you find this kind of stuff interesting, which I do, you can kind of poke around and see what all is in the OpenStreetMap data, and it's pretty rich. So we do have options for accessing data. I could put a bunch of links on here mainly to just help folks either here in the room or if you're catching us on the video afterwards, because there are some write-ups on different ways to get at the data. The takeaway kind of from my talk is we ended up choosing this Overpass API. It's read-only. It's optimized for what we're doing, which is pulling down data. We're not contributing. We're not making edits. So we're not using the mainline API. And it also allows or gives us the ability to filter, which we need to do. We want to filter to how certain tags of those power objects. We also want to query by geography. We're going to be pulling down by bounding box, but there's also geographic proximity operators in there as well. So it's a pretty rich syntax, I would say, for doing it. pulling it down or authoring the queries for Overpass. Take a look at Overpass Turbo. If you don't want to write this query syntax from scratch, they have a really handy wizard to generate the query syntax from a simpler kind of just key entry. And also, if you're not downloading a lot of data, you can just go to that site and download data directly. So you don't need to write Python code. You don't need to think about doing this for a large geography. You can just go to that site and download data. So that's the Overpass Turbo. So the data flow looks like this. Overpass API. All of this is automated in Python. So we're writing Python code to download some JSON in the end. It's an OpenStreetMap JSON, which gets transformed into GeoJSON. Then we step into the Esri or ESRI GIS database format, or we do a number of transformations to make this data useful for end applications and people. We did some spatial chunking. This is kind of a key part of making this work for this client. And I put this in quotes here, but essentially we're kind of chunking this whole operation up by geographic cell, by tag, and by geometry type. So we kind of multiply that all out, and that's how we kind of divvy up the data and divvy up the data download process in a way that won't overload their API. And you do some merging at the end, namely at for the geography. So we merge back together at the end. So if the customer ends up with seamless data sets, for example, of power plants or of power lines for that entire geography. Just a quick note about some of the things that you'll run into if you were to step through this process. OpenStreetMap has a categorization of nodes and ways, and that maps to the geographic information systems or GIS world of points, lines, and polygons. If you're not super familiar with GIS, commercial GIS like the Esri GIS does place some constraints on how your tables are organized, namely that table is homogeneous with respect to the geometry type. So you have a table of points for power plants. If the OpenStreetMap dataset also provides power plants that are polygons, you can't put those in the same Esri GIS table. They're going to be two separate tables. GeoJSON format does not have that constraint. Other systems that you might be kind of targeting might not have that constraint, but that's something that you have to pay attention to. And then we could talk all day about geospatial formats, but these are just the formats that are in play for this data transformation. I would say if you do any work in geospatial, you'll see GeoJSON pretty much everywhere. It's used a lot as an exchange format. And if you're working in the Esri space, their geodatabase format is pretty ubiquitous. Again, one of the nice things about that format, I would say, is that it operates. You can kind of write the same logic, same code, the same applications against this format. And in the single-use database format, or also they operate on top of relational systems like RDBMSs, like SQL and Postgres. Okay, so Python conference or Python data conference. So there's some Python code. Purists in the room would say, hey, that's not code. That's just configuration. Okay, we can talk about that later. But yeah, it starts with configuration for me. We see, hopefully this makes sense to you. We have some queries. Those are our cells. We see bounding boxes of lat longs. And then we have this map on the right that is encoding the key, the value. So like a power plant or a power substation, and then also the geometry type that will eventually be transformed into in the GIS. So that's a little bit of a look at the config. And the query itself, we're looping through these cells, these spatial cells, and we're issuing queries tag by tag, right? So we're going for power, we're getting computators, we're getting generators, etc. And then the query itself is here. So this is a template string or a templated string of the Overpass query. We're able to pass in the key, the object tag that we're looking for, and then the bounding box, and then we're just repeating, right? So talk a little bit about scalability at the tail end of this, but we're effectively breaking this problem up into multiple parts and doing it in series, right? We're not attempting to parallelize anything, but we are chunking it up out of necessity. Awesome thing about OpenStreetMap is it's global. Pay attention to your strings. If you want to pull in special characters, just pay attention to what you're doing with your encodings when you download. Do you want to grab this German language tag here, you're gonna need to pay attention to using UTF code, TF8 encoding. OpenStreetMap has a JSON format that, in my experience, I haven't seen anywhere else. So it's just the format that you get when you ask for data from this API. So do something useful with it. We transformed it to GeoJSON. I use the Python package for that, and it's called OSM to GeoJSON, and it does what it's supposed to do. We move the data into the Esri geodatabase. I'm kind of skipping ahead a step or two here, but I wanted to just group together the transformations here. I'd say one interesting gotcha that I ran into is we're using a coarse grain function from the Esri toolset that accepts JSON text, GeoJSON text, and transforms it into Esri tables in their database. And it was really interesting. I knew I had GeoJSON, but I just suffixed my text file with JSON, and the Esri tool just couldn't deal with that. It turned out I had to tell the Esri tool magically through the suffix of my file what was inside it, which if I just said it was a .geojson, all of a sudden we were good to go, right? So that's one of the perils of using a coarse grain tool like that. But once we got it right, we didn't have to write that logic ourselves. So a little bit of this has already been covered. We're into the Esri geodatabase, but we've got some merging and duplicate removal at this step that I wanted to talk a little bit about. So we stepped into the Esri world, and this really was a convenience for me. I knew I needed to get into the Esri database format for my client. So I had a convenient ability to use a licensed package from the commercial GIS side things, which is called RPI. This was a convenience, but on the plus side, I had access to some coarse grain tools to do things like data transformations. It's a really common geographic data operations like pens, merges, and even to delete the identical, or I should say the duplicate data that I could have. So I think if you think about it, since I was querying data cell by cell, there's a chance for some line data that I might have downloaded the same line twice, right? Because it spanned the spatial chunk boundary. So what I did was identify duplicates by using the OpenStreetMap ID. So there's a nice feature there. OpenStreetMap does have IDs. Use them. So there's the merge, and it's just, to illustrate here, this is one of the conveniences of being able to work, say, in a tool set that's dedicated to this commercial GIS world. I'm already in their data format, so they give you some tools, really coarse grain tools, to just do what I need to do rather than creating my own code to do that. It's a convenience thing. Didn't have to be done in the Azure space, but that was in the end what I chose to hear. And there again, just to illustrate here, this is the kind of merging all these cells all back together so that people have a seamless data set at the end. Speaking of the end, this is the close to the end of the data transformation. We want to talk a little bit about attribution and what that looks like. So this is a visual. It's showing a power plant in the commercial GIS software, and we're looking at the attribute and thought about this. Ifo, I've mentioned it. This is a power plant. If helpful if you haven't thought about this, Ifo, I've mentioned it. This is a power plant that got captured in OpenStreetMap as a polygon, right? So why did it get captured as a polygon? I have no idea, right? But it did. So it's the footprint of the property, or it's the footprint of the building. It's something that got captured this way. And so, and I mentioned this earlier, we had to grab it twice. We had to grab two sets of data, rather, the power plant points and the power plant polygons, and provide both of those to my client. the attribution all comes through in a nested JSON field. So this tags field that's highlighted in the square, that's where all the good stuff is. Not only the categorization of that power plant as a power plant, but its source, like it's a gas power plant, it's a combustion process gas power plant, it has certain megawatts, and even the names are in there, right? So some applications can use this data, or if you're writing your own application, you could access, obviously, just nested JSON, but the GIS application workflows, typically we wanted to extract those fields. So that was the tail end of this process, was to write some code to add some fields and extract the nested JSON into first order fields for consumption. So I told you I wouldn't ask any questions, or not too many questions I didn't have answers to. So here's some of the answers. The green dots we saw earlier, those are categorized as generation sources, and they're categorized as solar. So I'm presuming those are rooftop and probably residential solar views, so power there. And that's actually a wind farm. Those are turbines connect offshore wind farm there off the coast of Brightby. The mysterious blue circles aren't so mysterious if you think of them as power plants. They're visualized by their output, and so the lines are power lines. Again, there's a lot of information in here. You're a data center or internet data center company, like you are interested if you're near power backbone, right? Transmission lines, high voltage lines compared to the Meyer line. So that information is in there. And the field extraction that I just mentioned, all of it's clear that the tags field, it's still there with all that detail nested in a JSON object. But we pulled out the important fields that we knew we wanted to provide to our client as top-level fields. And in some places also did some calculations based on translating, for example, the watts to nabalogs for communications. I'm going to skip the demo today. I feel like when you're late to school, you don't want to kind of dilly-dally, right? So we got a late start today, so I'm going to skip the demo, but happy to, talk through this with some of you afterwards if you're curious. It's a pretty interesting exercise to just look at OpenStreetMap, go to data, and can see what it looks like. So if you're watching the video, you can do this yourself. You can take a look at tags in there and kind of find a tag that you're interested in and download it and visualize it yourself. Challenges and solutions before I kind of look at next steps, and just appreciate time so I could really close here. Learning to overpass query language was a little bit interesting. It's really powerful. You can do a lot with it, but syntactically, it just took a little bit to wrap my head around. There's some good examples out there, and I mentioned go to Overpass Turbo if you want to just enter in some searches and have that query language generated for you. But that's a helpful tip. Data sets are rather large, so we already talked about how we chunked this up by geography and tag. Processes were kind of long running. I really leaned on my configuration for that. I was able to kind of start and stop, or I should say restart processes from the middle, especially during development as things were failing in the middle and not having to go back to the beginning. And I did try to do some merging in the GeoJSON world, straight Python package for that. It just didn't work, right? So I knew I needed to get into that Esri space, so I decided to just merge inside the Esri space instead of using air tools. Future, I really think the biggest thing I took away from this as I was preparing was just realizing or the optimizations that were still possible with this, mainly parallelizing this, right? So being able to chunk this up was one step, but downloading chunks in parallel and then putting things back together after parallel processes have completed, that would obviously be a faster process. So that's something that I like to think, I'd like to take an opportunity to add at some point. Also looking more configurability, making it easier to define the geographic extents of the download area. And then really big picture, I'm looking for an opportunity to get a web front end on this, and all this Python code that's really just kind of a manual process right now, to run a couple of scripts, put that into the Python API so that it could be run with an application front end. So really appreciate your time today. My my contact info is up there here, and not sure where we are time-wise, but definitely happy to answer questions. Thank you.
Let's thank our speaker, and maybe do a quick